Good evening, everyone. How's it going? How's it going? Welcome to another stream. So last stream we were talking about basically rebooting the renderer and just recapping on all the different renderers. For now, that is just a previous VOD, but I'm hoping to cut it up and turn it into a YouTube video, so it's available on the VOD channel if you're interested in that. Today we're going to be beginning sort of rebooting the renderer and doing it again. But we need to start off by fixing our screenshot viewer, because it's going to be a very useful tool to be able to take screenshots and compare screenshots and zoom in and see pixels. So we want to fix that today, and it might get done quite quick. So effectively we're going to possibly do some other things as well. Hey there, Wajilla, welcome. How you doing, sir? Just tidy up here a second. Oh, there we go. I just knocked my shredder over. So I sort of shredded paper on the floor, so I just had to move that. Oh. Yeah, hey. Oh, by the way, look at this. So the stream should not die now. Look at that. So last stream we had that problem with the swap chain, and I've at least found a temporary fix. It doesn't resize smoothly though. But that's some other... I've got things to work on in the Vulkan backend, but that's not for any time soon. So basically, what was missing, at least for now, it's just so dumb. So the reason why, so my code, so there's a few changes I want to go over actually. Yeah, I've done a few changes since last stream. I guess let's recap those quick. So off stream I've been looking into this swap chain issue. When we used to aggressively resize the window, it would all of a sudden get a device lost in one of the shaders. So it would just basically index into a texture and write somewhere where it shouldn't. And what would happen then is it would crash and bring down the whole desktop. So I'm not usually too fond about solving those problems on stream, because my computer will reboot and then the stream will have to come back on. So yeah, typically I solve that off stream. But I'm hoping to probably buy a new graphics card soon. I don't know. We'll see how that goes. But yeah, so basically I just made some adjustments into the Vulkan backend where there's quite a few little ones. Yeah, so something I didn't have was a deferred delete objects queue, or, so something that we wasn't doing is destroying the temporary resources. So the memory was ticking up quite fast actually, but I just didn't know about it. Yeah, so maybe we click on that in the debugger. How does that? Not in the debugger, in the Right, does it tick up? Alright, let's follow that. Right, it's still ticking up. It's still leaking. I don't know why it's leaking though. But it might not be as bad, I don't know. Oh well, leaking is the way. So, yeah, we wasn't deferred deleting any temporary resources. I had to add these in, so from the front end we could say, destroy the textural buffer. So effectively the way this queue thing works, yeah, so at frame start we check 2 frames ago and see if those resources that were destroyed 2 frames ago Well, see if we have any resources from 2 frames ago, and we'll destroy those ones. So we'll have 2 arrays, right? And then frame 0 will fill in a couple of things to be destroyed. Frame 1 will fill in a few things to be destroyed. And then when we go to render frame 3, or frame 2, sorry, yes, frame 0, 1, then render 2. We'll go back and use this buffer, but before we use it, we check over the list and actually delete those objects. And then we'll add stuff to this list for this frame. So it's a typical approach you do with GPUs, because the reason why you have 2 is because typically you have the CPU fills up stuff for the GPU to consume, and then you send that to the GPU. And so while you're filling up CPU side, the GPU can be processing the stuff that it's been previously sent. So that's why you have 2 typically. So what happened with the swap chain? Yeah, so I didn't really change much of the swap chain off stream. I just made it so that when you acquire the image, it can fail. So I just made sure I handled that properly. So if it fails, we just set all the surface resource IDs to null and 0 in the dimensions and return false. So it's a completely invalid texture. And now we return false. So that means, so we handle that and say in the graphics side of things, yes, it gets passed up to GPU and returned out. And then yeah, I just basically skip the frame if it returns false. Here we go. So after this, you would start recording the command buffer, but now we just return early. So what else did I change in the back end? I don't think I changed much. I just added that deferred delete queue off stream. That was it. Good. And I investigated and found the problem to do with investigated and found the problem to do the swap change. So last stream was looking at that sample, the Vulkan sample swap chain recreate sample, and it talks about how they basically screwed up on the design of the Vulkan API and how you got to solve it. And it's, the workaround or way to solve it without the extension is quite crazy. You just basically accumulate swap chains. And then but thinking about it and actually doing some tests when you resize the window, you won't build up that many swap chains. Technically, you'll build up like just a couple, and then like you would end up freeing them, I think, from my understanding. So rather than sort of like solving this problem properly, I was thinking, because I know I didn't have the time to solve it off stream, and I wanted to figure out like if there's a problem with my Vulkan API under the hood. And I come to the conclusion that it's probably fine, except for the swap chain code. So then I'm thinking, but before I come to that conclusion, I was thinking, how can everyone else's code that uses swap chains use it in a similar way than I, and mine crashes and burns when I resize the window too fast. And then I've put in this texture clear. So I isolated down to this final shade here, which just encodes to the swap chain surface. So I commented out all the code in the renderer and just had this shader going. Resized it, still crashed. I took out the line which wrote in the shader which wrote to the swap chain image, and it did not crash anymore when you resize the window. So it wasn't the compute shader that was a problem, obviously, it was writing to that surface texture. So But what ended up happening is I commented out this compute shader and put down this clear operation, which in the Vulkan backend, all it does is call the it just calls the command clear color image, right? So it's a built-in thing. And obviously you pass in this will pass in the swap chain image here, or the actual VK image, into the function call. So what I found out is if I either called this clear function, or if I got rid of destroying the swap chains, what happened is when I aggressively resized the window, it worked fine. Obviously, if I got rid of the destroy swap chains, so when I resize it just accumulates swap chains, I'd eventually run out of memory on the GPU. And then, so yeah, so effectively what I'm going to assume, right? My thinking is that the driver has some magic solution inside render pass begin and texture clear and other operations that directly know that it's a swap chain image. And handle the case when you deal with swap chain recreation the original but incorrect way, right? And then basically like VK wait device and then like recreate swap chain type of thing. That's the original way you do it, but the way you're supposed to do it now is a more complicated way. So I imagine this is why I think like, because they didn't solve this problem until 7 years or maybe more after Vulkan had come out. So this code would have been working for so long, games would have been released with this, so they can't break it. So I imagine that they've got some workaround in the driver, and obviously because I was using a compute shader I was binding a descriptor set for the whole frame and using bindless. It doesn't, maybe it could go over the descriptor set update when you send an update, but maybe it's just easier for them to do it in a clear operation or in a render pass or something like that, and just check if it's a swap chain image and specially handle, wait a bit longer or something. I don't know. I have no idea what's going on. It's just an assumption into why this works this way. But yeah, so I think the solution would be to handle swap chain recreation correctly, right, according to this document here, basically. This sample here. Yeah. So I think that's the solution I've got to do long term, but I'm not going to do it for a good while because there's just no point. We'll just leave that in the code And yeah, a future version of me will pick this up. But yeah, that was my two. That's what I was doing in my lunch times past 2 days, is figuring out what the crap is going on when I aggressively resize the window. Didn't go good. Mostly got 2D normal mapping working. Okay. Right. Do you mean just like a normal map texture? Like, is there such thing as 3D normal mapping? Do people do it like 3D volumes? That's cool. So you get some nice detail, you know? That's cool. Right, so before we get started on taking a look at old code and redoing the tile binning renderer again, but better and with ellipsoids, we want to fix that super awesome texture viewer because it's just one of the most handiest tools. So right now, since we added screen resizing, the screenshot, we got a screenshot that comes from the every time you press F12, it saves a screenshot to the screenshots folder. This is not in Git, right? And it saves it as texture 0 and texture 1, but also another copy is saved to a timestamp arranged thing here. And I just learned as well that Windows doesn't have colon support in file systems, so we might have to make those dashes. But anyway, so the great thing is when I want to compare it with an old screenshot in the past, I could just copy it and make it texture 1 or texture 0, and when you boot up the game, it just loads it in straight away, and it also would just remember your previous one you've taken a screenshot for. So that's pretty nice. The problem is, since we added screen resizing support, the size of the texture could change. So it was no longer a fixed size. So I just temporarily made it 4K, and then this happened. So I even need a way to... I need to figure out what I want to do basically with these screenshot textures. Do I recreate them every time there's a new... do I literally have a way to recreate some textures and resize them? Some static textures? Or do I... and also, how do we handle when two of the images are different sizes? Can we... Does it mess up with the way the scrolling is? Is it center aligned, or is it top left aligned or something? I don't know. Yeah, but it should be bottom left or something. I don't know. Anyway, stuff to figure out. Normal mapping for sprites. Oh. Right. Why would you do it for sprites? How are you doing like a 2.5D game where you got billboards and stuff? And I guess the sprites are not low res pixel art, they're kind of like a little bit higher res maybe. Just allows more freedom with the style of the 2D game. Yeah, but so normal mapping is used for, you know, you do the n.l, the normal dotted with the light direction, right? And you get a different multiplier to apply to the color. Where's the light direction coming from in a 2D game? Is it exclusively a 2D game? Right, so we have two types of textures in the code base. We have static textures and temporary textures. Temporary textures are at most a frame lifetime. So you allocate them at the beginning of the frame. Oh no, at some point in the frame, and you can deallocate them manually at some point in the frame. And if you do that early enough, you can get memory to be recycled and reused within the frame. So it's quite powerful. But these screenshot ones are static, right? But they can change in size, which static textures do not have the capability for yet. If I add that feature, then it means that, yeah, I might do it. I think that's the most easiest way to do it. It means that yeah, we don't have to add anything else that is any sort of other special type of texture or anything like this. Yeah, so I think we'll add that support. That sounds all right. So we've got we're actually using a heap allocator under the hood anyway. Like we made it for the well, I had this heap allocator for the BVH nodes, then I took it and changed it to be bytes instead of node elements. And yeah, we've got this pretty cool heap allocator, which allows us to allocate reasonably quick and also you can deallocate elements, put them back in, and then the memory can recycle throughout the frame. So currently there's two of these. Or is there more? Yeah, there's four of them. There's two for the buffer, two for the image, depending on the lifetime. So static lifetime and temp lifetime. So there's one allocator for static buffers, one for temp buffers, and same for images. Which means technically in the static one, we can actually resize it. But it shouldn't be something that we do all the time, because that's not what it's built for. And since it's for debugging, it makes a ton of sense. So maybe we'll yeah, so since it's for debugging, it makes a ton of sense to break the rules in this case. So I think we want to have a way to say GPU texture resize. Now, so you want to be able to specify a new set of dimensions. And I guess it will not copy any memory. We won't really care about the MIP levels or anything like this, no. Well, we could technically do MIP levels and array layers. So the problem is if you have any image views, those would have bugged up. But I guess you want to be able to recreate the image view as well sometimes. Or texture view. We could call it re-init. That might be a better way of saying it. Yeah, so re-init. something like this. Then you have an alias. Hey Voodoo, welcome. How you doing, sir? I believe Godot supports this feature. I handle everything in 3D just to make things simpler, so my lighting is almost exactly the same as 3D. Right. Okay. I think I see what you're saying. Yes, you have a light that's just positioned in front of the character. And then you can do the... Right, yeah. And then you can make it... You can make effectively... Yeah, parts of the sprite look darker. And other parts of it look lighter with the normal map, yeah. It's cool. Doing pretty good. Finished one uni project and now thinking about making a second one, like 3D game for another project. Cool. Nice. Just jamming through these projects. That's great. What are you what technology are you gonna use? Thanks. Yeah, my mum got it when she went somewhere in Europe. I think it was Spain. She got a couple of them. I gave one to my mother-in-law. Great. It's glass. You know, whenever I go places where I'll take it with me. Cause it's yeah, it's nice. Much better than drinking out of plastic. Oh. I'll put it here. So we'll call it re-init static. Just to... Right, drop that in there like that. So... Alright, it's going to be good. So we can probably start with the texture view because it's going to be the easiest, I think. Yeah, so there's SDL2 OpenGL, SDB image, and maybe some 3D modeler. Cool, nice. Yeah, we could wait. Is this your first time doing a 3D thing? Right, where do we do some checking? Here, isn't it? These are the checks. Right, mid levels are 0. So we take all of this. Yoink. And then we'll right, so allocates a new one of them. So we take all of this. So obviously it's not allocating anything. Oh, I put in the wrong one, didn't I? Of course. Alias. Aliased. Right. Oh, you need like a basement level, do you? Of course. Of course. Nah, but I'm a newbie. That's cool. I feel pretty confident that I can make a full 2D game with my engine and render it, but I can't say the same for 3D. Awesome. That's pretty great. Great place to be. You know, Yeah, 3D is one of those things where it is definitely a lot more work. But after you've built, I think what I could say is like from going nothing and learning 2D development, you could probably say that difficulty that you found to achieve that is probably another one of that level of difficulty again to do with 3D. All the because when you do 2D, you have to learn about like graphics APIs and platform stuff like using SDL and how do there's lots of things you have to pick up on. How does rasterization work? How does um, but then when you go to 3D, you've just got you got a sort of another layer of things to learn, and it can get quite complicated, but you can avoid a lot of it. Um, yeah. You have to make sure you know your maths and stuff. But if you know your maths like even more than just the basic like vectors and matrices, you can do some real complicated stuff in 3D with like physics and stuff and rendering. How big is my project? About 4 meters by 7. No, I'm joking. How big is it right now? Have I got a clock? I think I have. The maths is the most important part. It is. It is because like it's quite important. Like you can definitely pick it up as you go along though. But yeah, I wouldn't avoid it. So yeah, this is how big it is apparently. Why is it this big? What's making it that big? Well, what's this text? Okay, hang on a minute. I made a temporary file where I dumped all my swap chain output. Let me run it again. There we go. That's where's all these I've got another text document somewhere which is just apparently too big. So yeah, about but why is it that much? Is it already 40,000 lines? Yeah, that includes my maths library. If I go into my third party, that's all code generated. 22,000 code generated. Yeah, so half it comes from there. So then like in the source folder, just this game and engine thing, we're looking at apparently 32,000 lines of C. I don't know how we got that. There's some code generated stuff. It's not handwritten. So it's not really a good metric to be honest. I do a lot of code generated stuff now. The maths is a bit scary. The shaders for 2D were easy, but 3D, different story. Yeah, this stuff you gotta learn, but you can tackle it bit by bit. Because I have my CPU and GPU usage low when I'm in game. Hmm. So it's probably because the game is single threaded, my guess. Unless you got like a low power mode on your... Well, low power mode would clock your CPU down, wouldn't it? Something like that. Right, so we update... So we reinstantiate a texture view. We'll just set the properties. We'll set its memory state to initialized again. We want to have a way to deallocate the... So in the Vulkan backend, I added a way to resource DNet type of thing. Texture DNet. So I just need to rename this to texture DNet. And that ought to do it. That'll be reusable. Right, so where do we use those in GPU? So temp, texture. So at the end of the frame, go over all the temporary stuff and just de-init them. Right. So you go to re-init. We should now be able to call GPU backend texture de-init and deinitialize the state that's already in here. We probably want to do that first, then change all this state. So what this is going to do is just add it to that deferred queue. So 2 frames later, it will actually get destroyed properly. So it takes the VK image and the VK image view handles. And then we want to call GPU backend texture init after we change the stuff, and pass in res ID and resource. Then if it's static, which it always is in this case, get the alias resource and set it to allocated. Right, texture view in it. What it's got to do. Alright, that seems pretty alright. Probably put that at the top. Right, so we save that. There we go. We don't need a dims in there. That's a bit wrong. Dimensions for a texture view will just be inherited from the other one we're targeting now. Yeah. Cool. So let's do the texture re-init. So I guess we could take most of this again. All right. I guess you could change the you could technically change everything about it, you know. So texture initialize, reinitialize, we could probably change the format as well if we wanted to. You could also change the type and the name, but there's no point doing that, I guess. We can add it if we need it. Well, in that case, we could probably do the same thing about resource type and format. Yeah, I don't think we need them. We can always put them in. Right, so when you reinstantiate a texture or a static texture, we don't bother changing the type stuff. Right, there's a max texture size, which doesn't really have to exist anymore. I think it's the maximum size texture we'll ever make anyway, so we'll leave it in. Here's some extra requirements around the it being a static texture. So let's get the resource that we're trying to edit. So if it's not a cube, or it's got to be not a cube or 6 layers. If not, it will fail. There. Right, we set up all these things here, and then initialize. But before we initialize, we want to make sure we de-init the texture. So great. I think that's all it will take, right? So this will make it so 2 frames later, the VK image and VK image view will be destroyed 2 frames later. Oh crap, we didn't reallocate the memory. Yeah, we still got to do that. So when we initialize, so in here, we want to say if it's static. So this is saying if it's alias raw. If it has an alias, you want to say if it doesn't, then do this, right? Cool. So within here, we're saying it's not a texture view. So you free the image in 2 frames, but we also want to free the allocation. So actually, we need to pass in a pointer. So I need to add a new type of deferred object, and we'll call this static memory. I'll just call it static texture or image. Well, for instance, I call it image in Vulkan because that's what it is. Yeah, static image allocation. So in here we'll pass in memory block. Like that. So we'll add a new one. Static texture image mem block. So that will be a GPVK mem block. Like that. So that gets added on, but we only want to do that if the resource lifetime is static, right? And then it should mean that we can copy this, find where we do a defer delete on the image, and just throw this in here. I don't know how correct it is, but I think you should destroy the B first, then image, then the memory block. That makes the most sense to me. I don't think you need to do it that way though. So we've got a function in the Vulkan backend called like memory allocator block deallocate, and we'll deallocate. So the allocator is ggpu vk memory allocator for an image with static lifetime. And then we pass in the memory block. Cool. So that will, in a couple of frames, defer delete the memory block. So let's just double check quickly. So we go to GPU. When we reinitialize the texture, we call this dinit. That's when it will do the defer delete stuff. Then when we initialize, it should, it creates the image. Yeah, then it allocates more memory. Perfect. So that'll be good. So now all these reinit functions. Let's run the game some more. If we simply just, so now when we do these screenshot textures, we go, what is the size of the screenshot? We'll recreate it, and then we'll upload. Yeah, so as soon as we build up the game, I think we'll create it with a single pixel, and then when we get to the initialization code, we'll throw that old one away and create the new one at the size that it has it on disk. And then when we press the F12 button and take a screenshot, we will take the screenshot dimensions, create a new texture, and that's where it will get copied to. Yeah, so that shouldn't be so bad. That'll be pretty sweet. Yeah, I think you got to be careful. You've got to make sure that you don't allow screenshotting while you resize or something, but hopefully no one's doing that. So yeah, let's tackle the first one. And the second one, I think we try the screenshot button out. I think it crashes, so we can investigate that first. So when we instantiate the screenshot texture, we're just going to initialize it. I don't think we need a max width. I would like to get rid of these. And my suspicion is that is probably not possible. Oh, right, the UI tiles and chunks could just use the, yeah, let's get rid of these constants. Oh, I want to get rid of them. We'll get rid of them later. So make it a 1. Then we'll take this, and when we go to actually upload to the screenshot, here we go. So use STB image, do a nice load, gets us the width and height. So all we have to do is recreate. So we re-init. Doesn't take a texture type in or anything like that, or a format, just the dimensions and that. Oh, you need the original resource ID and all that stuff. Right, then you say it's got a width of that and a height of this, and then I'll memcopy it into there like that. Cool. So same thing for this one, but with screenshot texture 1. So we have 2 screenshots which get uploaded at the start of the game. So we can compare these things, obviously. So let's give it a run and hopefully that works. If the stream dies, I'll be right back, but it should be fine. TM. Right, validation error, that is to be expected. We need to probably restart the yeah, I understand. So where's the sync? There's a place where we, oh, where is it? We do an axis 9. Yeah, you want to clear their before states. Yeah, so here's what we do for the texture, the temporary resources at the end. We'll reset the sync state. So maybe I can call that a function, say like reset. It'd be internal. Maybe we'll stick it here with a start. No. We'll stick up with the resources. Seems alright. So we'll call that sync state reset. It's a bit of a long name though. Be a resource sync state reset. So that'll be pretty handy, because I did it in a few places now, so probably a wise idea. Interesting, we'll put it under there. Nice. Ah crap, I should go back and put that. Nice. So I want to put this in the Vulkan layer. So we can get rid of those two lines there. When we reacquire the swap chain. And the sync state needs to be reset when you recreate the texture. So maybe like that. Nice. So let's take that for a spin and see what happens. Yeah, quaternions are effectively the way you want to do rotations when you're not using a matrix. Yeah, they're pretty handy. If you just want to store the rotation component separately, you store it with quaternion. Oh. Right, so we bring up the screen, the texture viewer. Nice. So now we don't have that extra stuff here. This texture was specifically created because of the size of the texture on disk. Right, so that's cool. Right, so the next thing to fix is when you press the F12 button and take a screenshot. Does it work? So that worked apparently. Oh, okay, it comes out blue. That's because of the good old swizzle. And as you can tell, the size is wrong. Our old screenshot was actually bigger. So what ended up happening is when it copied it to it, it just didn't fill it up. But the screenshot Oh, and the screenshot that landed on disk is actually, this one's in RGB. It's the other way around. Isn't that funny? But it's still inherited the previous image that was on it. Okay. So I'll figure out. So I changed the way I did my textures in my shader compiler and made it better. And in doing so, I removed the so now auto swizzles all that stuff rather than manually having to swizzle it in the shader. So when we do the read back, so when we press the F12 button, we issue a, whenever we press the F12 button at the end of the frame, right at the end of the frame, we take, what are we taking? The surface. So that would have been encoded as, it might not be ideal. So the final frame will probably want to be like a HDR texture. At some point. And then this is going to encode to surface, is going to do the condensing down. But it'll be an sRGB at this point, so I guess that's probably okay. But if the screen was HDR, it won't be good. But I guess we can solve that later. So just as a texture copy. So what we should do here is do that texture reinit thing. Right. This is step one, get the right size. Now, one thing I didn't assert on is that it's static. Where's some assertion I can just steal? That one, thank you. Can only reinitialize temp resources. Oh, sorry, static. Because temp ones get recreate every frame anyway. And static ones you don't really want to do it for much. Cool. I guess you could init the texture view this temp. But yeah, well, add if we need it. I don't think we'll need it. Right, so here you'd get the size of the surface, and we've already got that in surface dims. So we recreate the static screenshot texture, then we do a command to copy to it. So quite nice. Wait. Yeah, copy to it, and then we read back the result from the screenshot texture, and go back into this readback queue a couple of frames later. Then it does the BGRA conversion to RGB. So we might not need to do that anymore, apparently. I don't know. I think that's right. No, because we did it. And it looked great on disk, right? Yeah. So that means when we read it in, That's a BGRA texture, isn't it? Right, the format needs to be the same as the display. That's why. And then we'll need to do the BGRA conversion. So use BGRA there. And then when you upload it, you need to do the BGRA conversion, which I deleted that code. I can bring it back though. Okay, that's fair play. Yeah, they're also like closely related to rotors and like geometric algebra. That's stuff which I still need to kind of learn, to be honest. I just know how to use a quaternion. I know there's like an explanation for it as like a 4D sphere, hypersphere, right? But that just, yeah, still haven't sort of understood that part of it. But there's the rotors side of it, which explains quaternions using geometric algebra. Were like effectively like, yeah, I can't really describe it. Well, yeah, you have like there's this different type of algebra basically. Yeah, so now I need to do the conversion from RGB to BGRA on Windows and Linux. So actually the screenshot one should probably be whatever the GPU surface format, is that what it's called? Format surface SDR. Yeah, the SDR format. So on Linux and Windows, it's 8888 BGRA. And then that BGRA conversion, I had it in a previous version. I don't know when I think I removed it when if I git log it. Where is it? Switch over to latest HTC stuff, right? I think this is where I bugged it up. What about right? Still not far enough back. It's probably at screen resizing. Math is always concepts that aren't really programmable, like I don't think a tensor can be represented in code. Right. The answer that made sense for me was as an extension to complex numbers, and once you learn complex numbers, you realize there's sort of discrete form of rotation. Okay. Okay, yeah, the explanation, right. Cool. Complex numbers represented as 2D vector rotations. In the same way quaternions represent 4D vector rotations. Right. That's where my mind just completely loses track. Yeah, I've been trying to learn some more maths off in my spare time, but the problem is I spend a lot of time programming and thinking. It's difficult to sit down and just learn stuff that requires sitting, down and thinking. But maybe, I did ask my boss if I can cut out 15 minutes a day and learn maths. Right, here's the code I was looking for, and he agreed to it. I did it for like a month, and then I stopped doing it. So I really want to pick it up again. But using complex numbers, I was going through and learning all of the basic fundamentals of maths from the beginning, because I did do maths at school, but I wanted to make sure I wasn't missing much, and also sort of build up an intuition for it a bit more, by practicing. But yeah, I should really get back into it. What's this game to eventually be about? That's a good way to phrase it. Eventually, it will be about. Eventually, it'll be an RPG. So top-down RPG of some kind. Still need to plan it out. I've had some sort of game design idea that I wrote down initially. Not sure if I'll go with that one, but definitely the same sort of idea around it. Yeah. So yeah, I think what I got planned out is 6 months of working on editors, so we can make custom models and materials and levels. And then 6 months of doing some further rendering. After this sort of rendering, quick little reboot of the renderer, which will then, after doing that extra 6 months of rendering, so that 6 months of rendering is going to include probably better materials, GI, lighting, shadows. Just make stuff look a little bit nicer. Just make it visually look a bit nicer, and then move on to actually doing some gameplay and things after that. So probably another year away from gameplay, to be honest. Somewhere around there. Like I said, imagine the imaginary numbers concept. If we're going to point out on a 2D graph, it'll be somehow rotating them between the imaginary y real axis. Right. Huh. Right, so where's the upload code? Here we go. So I should be able to in place, and I gotta get all these damn extra lovelies from Git. Trying to be nice. So from RGBA to BGRA. Maybe it's just the same code as below, but it does it in place on the buffer. But anyway. Could have wrote it out manually, but there we go. Nice. So I need to do that on both the uploads. There's only 2 of them, so I just copy pasted it. Done. And voila. So if we F9, there you go, the image is now BGRA style. Now if let's do a different sort of, let's do a nice pink. We'll do that sort of like purpley emissive, where it's not really glowing, but that's something to do soonish. Press F12, take a screenshot. Takes a screenshot. Then we're going to change it to so this, I think is it Alt? Remember my keys. Frame submit. Alt. Press Alt F12. It's going to put it in the alternative slot. Press F9. So here's the look at that horrible edge. This is what we're going to fix in the new renderer reboot as well. Get nice anti-aliasing. But yeah, there's a screenshot. Isn't she lovely? And then we can go to the alternative one, which I took the second time around, and there it is. So the beautiful thing about this is you can flip between stuff and compare two screenshots. Something I want to try is the following. What happens if I were to resize this like that and then take another screenshot? So Alt, well, let's just do F12. Now I'll bring it back out to about here. Press F9. Right, here's the other one. Right, so the zooms are a bit different, but they end up staying in the same place, kind of. Yeah, they do. This somehow. Yeah, it's a bit. Well, not in this case. It might be around the center of the image, or is it around the bottom left? Definitely not. Is it around the center? Yeah, I think it's around the center of the image. That's okay. We can live with that, but just to understand what it's doing. So yeah, when you take two screenshots, ideally they should be the same size, and you can compare. That's okay. Cool. So I think this is everything we want. Right, so they get saved out like this. See they're here on disk. It's all right, isn't it? Right. So this is what we wanted to achieve this stream. We've still got like another hour to go. So I want to try and work on something else in the meantime. We could have a bit of fun and get the... We could either look... We could either do the time API, because I kind of wrote the API out, but didn't write the implementation. And we'll probably want that at some point anyway. Or we can look at Vulkan validation errors or something like this. Yeah. Or we can try and remove that max max display width thing, because it'd be nice not to have a maximum. Yeah, if we remove these maximum texture sizes, actually, that would be ideal. So we'll look at the UI renderer, we'll look at the screen tiles and hopefully get it to allocate them every frame. That should be good. Right, I'm just going to take a quick break and get another drink, and then we'll tackle this problem and maybe get to doing the time API after that, like, you know, taking two timestamps and diffing them and stuff. Right, POV. Alright, welcome back everyone. So yeah, I want to clear out this, get rid of this sort of max display dimensions. We don't really need it anymore. And I wanted to get rid of it from the GPU side of things as well as a max texture dim. I had this in there because for the texture viewer. Interesting. So we initialize a right. Texture copy texture. Well, we copy the texture. Interesting. Right, let's put the display ones back for a second. We'll tackle one at a time. So the texture viewer has a copy of right. Then we only display a portion of it in the UI system. So if we were to say every single time you select a different texture, or if the texture dimensions have changed, you can recreate this texture. So maybe you instantiate to 1 by 1, and then every single time, where would you do it though? At the start of a frame, you see if there's a selected tab, then you reinstantiate the texture copy texture, something like that. I think it's possible. So yeah, we wouldn't have to have this UV dims anymore. Or UV dims would just be 1, wouldn't it? Yes, that would just go. So what you could do is we can do a frame start. Here we do something with the texture viewer. So what we can say is we get the current tab. Yeah, we can make another function. We'll call it we'll say something like resize if needed. Something like that. So yeah, we'll get the current tab. And in the texture viewer, you'll have a default resolution. Oh, right. Yeah. In the text view, you'll have a the actual resolution of the texture. Copy dims. Copy resource dims. Copy texture dims. So that is how big is the copy texture. No, I don't think you need this resize if needed. What you need is a when you dispatch the copy and actually use it here, you need to get the current resource and say if resource if any or if all of them are not equal, the resource that we're trying to copy at a certain point in the frame to display in the texture viewer. So we get its texture dimensions, and we're comparing that with the ones in GPU texture viewer. What they're called? Copy texture dimps. That was it. Nice. Cool. Then we'll simply just recreate that texture viewer copy texture resource with the new dimensions. So that's using that reinit thing, GPU texture reinit static. We're passing the copy texture resource ID, and then the new dimensions, then one MIP level, one array layer. Nice. So I think that will be how we get rid of that max texture size. So that internal copy texture, which just exists to make a copy of the current resource we're trying to view at a particular point in the frame. It will just get, if it needs to change size, it will change size to fit exactly. Cool, so that needs to actually get instantiated to probably 11111. We did see what was it called? It was the this one. So we manually initialize these built-ins, and I guess we'll here we go. Nice. Rightio. So let's see if this doesn't break everything in existence. So we've now got rid of this sort of GPU max texture dim, so no longer is there a maximum texture dimension. Hopefully this still runs. Right, so this is because I thought I removed that UV thing. What was it? 1540. Yeah, so there's a function that takes explicit UV ranges when drawing a texture. Right, I've got a validation error by the looks of it. Crap. What is this? Right, something's wrong with our memory allocator. It seems that, so the way the memory allocator works is you ask for a size. So the way it makes the allocations quick for a heap allocator and reduces searching is you have basically this linked list of buckets. So these are in one big array, and this one points to the next element in or the next block. So each of these things are a block. They hold information about a range of memory that we could allocate. So when I ask for the size of 16, it's going to look in the ones which have at least a size of 16 and above. So this linked list contains stuff between 16 and 32. When I ask for 32, it will look in this linked list and only go in the one which has a bucket sizes of 32 and over. So it means what I can do is just take the first entry all the time and return that allocation. And then this becomes the new head of the linked list. So what's happening is we've got one which is actually smaller, and that's bizarre. But we do have some test code, so maybe we can figure that out on how that's happening. We could run. Yeah, it's just weird. So init static. So I made a couple of ones, and then it's. Wait, does it keep happening? Hopefully it does. Good. So it's reproducible. See, I changed it to a 1 by 1 by 1, and then a texture in the future. So it's not inside GP, it's in graphics. Has a problem allocating. So I think this one is maybe. Oh no, I don't understand. Right, so in GPU Vulkan we have a lovely function called validate. So validate just makes sure everything is good. So basically after every single allocation, we could just run this validate. And that'll help us find out. So this is allocating, yeah, we'll do it. Ooh, this is for the buffer. This is for images. So if it will, right, so we put that validate in. All it's going to do is go over all the blocks of memory and sort of make sure they all link to each other correctly with the linked lists. There's a few different types of linked lists. And make sure they're all the right sizes, and the right sizes are in the right buckets and things. And so it should trigger before the no, it doesn't trigger. Why is that? Look at the validate. So the validate should look at the linked list. This goes over all the blocks. The linked list which tracks the blocks which are physically contiguous in memory. Or that point to the memory which is physically contiguous. So there's like a next block linked list basically in each block. And it just visits all of those. Then it visits all the unused blocks. Then it visits the different free lists. And it should ensure that their size is correct. It does. So yeah, that's the code right there. How do you know what buckets to look in? So the way you do it, or the way I've done it, so I actually had this idea a long time ago, then I realized there's a paper where they do it in a different way. Where it, yeah, I've not actually implemented it in that other way. Of course, it's like a TSB allocator. Is that what it's called? I think someone else will know what it is. I forget what it is. Maybe it's a TSB allocator, I'm not sure. Nope. Yeah, I don't know what it's called. But effectively you use the, there's an intrinsic in x86 and ARM processors. TLFS, that's it. Yeah, there's a paper on it which does it. I think it does it in a better way, but I've not bothered trying to implement it. I think there's a bit more complexity which I didn't like, but it allows you to sort of search for. No, you have to keep something sorted, I think it was. I couldn't quite remember, but I should look into it again. But yeah, take a look into this. But effectively, the way you get the bucket is you take the size and you get the next power of 2. So you can use the... if you look for the most significant bit, which is set, there's an instruction for this. So unfortunately, the instruction is not directly exposed on Windows, so you have to use bit scan reverse. But it's called count leading zeros. You use count leading zeros, you can basically work out... Yeah, you can basically work out which is the index of your most significant bit, which is set. And that will give you the... And if you add 1 to that, that'll be your nearest power of 2. Oh, sorry, yeah, the next power of 2. So if you do 1 shift left, power of 2, it'll get you the actual number. Right, it's in log 2. And with that, you can clamp it between a min and max. So I've got a min and max power of 2 size. So, 13 powers gets you 8K. So my minimum, the minimum size it has to be stored in a linked list is 8K. And the maximum size I've got is 26, which is like, was that 64 meg? Yeah, 64 meg. So, yeah, then I just store all those buckets in the allocator here, where I just store like a U16, which points to the block in this block array. So you index with that. You index with that log 2 power of 2 thing that we got with this thing. Or you do this power of 2, take the min, and then you index with that. So the buckets can be empty, so you have to go over the buckets. Go over the buckets and find the one which actually has a slot. But it all should be pretty... It's all in cache, so it should be quite fast. It's not searching over linked lists. And then you just take the first block, and then it should always be the right size. So I put the assert in here because clearly it wasn't, which is weird. Two-level segregated fit allocator. Right. Sounds very technical. A power of 2, interesting. Was it? I don't think so. Doesn't look like it. No, it's not power of 2, because only one of these bits will be on if it's power of 2. No. Yeah. You wouldn't have a power of 2 of these numbers. You would have be 16 would be the nearest one, wouldn't it? Or 17 something. Maybe. But yeah, these are quite big though. Are they quite big? Yeah, it's 134 megabytes. Who gave who permission to do that? It's quite big. Isn't that like a 4K texture? Or something? Oh. It is, it's those 4K. No, I ain't got any 4K ones. I know, let's just run it and find out what they yeah. Oh, there we go. So it's in 178. The environment map dims. Right, is that was it the pre-filter? No. Oh, but it's got a bunch of MIPS. Yeah. Radio. Okay. Right, let's figure out what's going on here. So we could put a breakpoint in here. Or we could put the breakpoint in the allocator. If size is greater than or is equal to this number. Greater than or equal to this number. Right, let's give that a run. That should hit the breakpoint. Nice. Let's get in there. Cool. So what goes on? So buzz bucket, which is 13. Now, if I remember correctly, there's a thing called right, 26 take 13. Yeah, you're gonna be in the biggest bucket. Ah, I know what's going on. My biggest bucket is 64, which means you've got to actually search for, right. So actually we need bigger buckets. Yeah, no. So to save having even bigger buckets. No, you would need. Crap. Yeah, right, so 64 meg, 128, 256, 512. Yeah, and then that would obviously be yeah, that'd be 1 gig. So that'll support up to 1 gig of texture. Maybe we'll do that. Yeah, that was the problem. Alright, let's just do that. Shouldn't be a big deal. Right, let's get back to what I was doing. So we removed the we made it so that the texture viewer copy texture resized whenever you tried to copy to it and it was wrong. So here it's a different size and here it's a different size. So it seems to be working. Let's open up like the depth texture. Seems alright. Yeah, it's just able to resize the copy texture. So this texture here is a copy of the depth texture and displayed in the UI at the point in time where we've clicked on. Right. And there's the final frame, gets cleared, UI rendered to it. There's also a scene texture as well because we've got the editor open. Rerun it. Cool. Right, I'm glad we've removed that maximum now. The other maximum we wanted to remove was the UI system. We were using it's the last user of this max display thing. A display which was 4K. We can get rid of that now. We've got these things called temporary resources, so we can allocate this every frame, and it could be frame lifetime. We're actually shorter than frame lifetime, which would be great. So let's take a look at how the UI renderer works, just briefly. There's a debug thing we can enable. Right, debug chunks, debug tiles. So chunk bins, oh look at this, past Henry, look how neat and tidy he was. So effectively we produce an array of draw commands, but they're not necessarily a draw command as you would think in OpenGL or Vulkan. It's just an array of it's an array of draw commands, and each draw command is an array of sign distance field operations which are executed linearly in the compute shader. So it's a bit crazy complicated, but it's quite cool and flexible. You can do some nice animated stuff, but it is a bit slow, to be honest. So at first it bins them into chunks. These are chunks. Each chunk gets an array of, it copies the operations into each chunk. For some reason I think something's going on there. Anyway, oh well. Then it goes over every single chunk and takes the draw commands from the chunks and then makes an array per tile, and it bins them into each of those tiles. There's probably better ways to do this now, to be honest. As each tile has an array of draw commands, and then the cells. What are the cells? The cells. Yeah, the cells are the waves which execute. Why are my cells wider than the... Something's wrong there. Something's wrong there. Cells shouldn't be that wide. Right, number of tile dims. Yeah, I don't know what's going on. Let's ignore that cell one. But anyway, let's go back to the this should just be in graphics. I don't know why it's in this damn header file. I got a heat map and everything. I got debug ABBs. This is fun. Let's look at these. Oh. What about it? 1024. Hey there, Kit. How you doing? It's a good number, 1024. Right, it defines a thing called ratio. Hang on a minute. Get out of there. Alright, let's try the heat map. It's cool, isn't it? So it goes to show like how many draw commands are in each tile, basically. So this is where the dragger, like the slider thing, I think? I don't know. This is where all the actions are for the Right, then there's also a way to do visualize the bounding boxes of the commands, I think. Huh. I don't know. I don't know what this thing is down here though. It's a bit weird. AABB outline. Visualize an outline around the draw command where the center point is. You can enable both of those at the same time, I think. Debug run all tiles. Enables for benchmarking. So a full screen worth of tiles run all the time. I only run tiles which have draw commands. It's using a dispatch indirect. Anyway, I didn't turn that one off. So this should do an outline with a center point in each draw command. I don't know, it wasn't that. You can see the outline, it's a bit big. There seems to be some stuff in the background. Oh no, that's the tab. Right. I see. Cool. Yeah, so yeah, Akraz, I've fixed it. It's a bit of a bugger. The right, maybe my screen tiles are something's going on here. But yeah, effectively I think there's a maybe I can go over it in a bit. So what was it? So effectively I have to put this clear in here. There's a big old comment on it. So I disabled everything. Then I enabled the final shader, which wrote to the swap chain image at the end. And as soon as you write a single pixel to any location, I just tried running it to 000. It will crash if you resize the window aggressively. So there were two ways to fix this that I eventually discovered. One way was you don't destroy any swap chains, and then you run out of memory eventually. The second way was you put a texture clear in there, and this texture clear uses the built-in Vulkan VK command clear color image, right? And you pass this distinction is probably important. It passes in the VK image handle directly, right? So what I think is wrong with my code is that I'm not doing it according to the spec, right? I think that is true. My code in the back end looks very similar to what people do online, and everyone's like, this works fine. And also I've done it that way in the past, and it has worked fine as well, hence why I've been so confused over the past couple of days. So what I then came to realize is that what is probably going on is that the driver is probably okay. So this sample that we've looked at last stream, you know, it's like there was this bug in the spec for like 6-7 years and everyone was getting on fine apparently. But when you read it, it's like technically yes, this is true and we should fix it, right? So yeah, I'll drop the link in chat if people are interested in reading this monstrosity. Absolute epic fail. So games have been released for years with this bug potentially. So that must mean, right, driver vendors must have known about it, right? Because they wrote the driver, they must have known about it. And they must have handled it in some way. So I'm thinking the way they would have handled it is with some magical solution where, like, if you use a swap chain image or something like this, it might wait or something. It might bookkeep something just to make sure you don't, or it would either wait for the image until it's like, yeah, I don't even know, right? Because it's to do with like if you destroy the swap chain image or the swap chain, it will get rid of all the images go, and that will mean if the swap chain is still being used by the presentation engine, it's a big no-no, right? So I reckon they've got some magic in like these functions which clearly take in a swap chain image, like if you begin a render pass, right, you clearly take in a swap chain image handle, or and then you clearly take in one when you do a clear operation. But when I do a dispatch, I bind a descriptor set at the beginning of a frame, and I index into the descriptor in the shader, right, using binderless. So I imagine the driver doesn't really have a way. It does with update descriptor sets, but I don't think in this particular version of the driver, they've actually handled that. So I imagine this is where the magic is happening, basically, is in stuff like this. And this is how I can possibly explain why this workaround works. But again, it's just a complete theory. I have no idea. So yeah, that's staying in there now. I have a big old comment, and a future version of me will look into this and see if doing the recreation properly actually solves the problem. And then I guess that will validate my theory even more. If not, there's something else that's wrong, but I've looked everywhere and I'm pretty sure. Yeah, I've looked everywhere. I'm pretty sure there's not another problem. But yeah, I don't know. That's the where we got to. Well, I looked it off stream, right? Because it would just crash, and it's not really a good thing to do while streaming. And it feels like you have to have a deep dive into Mesa and possibly the kernel for that. Yeah. Yeah, I've never really thought about getting into kernel dev, to be honest. Well, I found it kind of vaguely interesting, but I've never really actually dipped my toes into it, shall we say. I've always been kind of like, oh, it'll be cool. But I think games more. So yeah, what was I talking about with this UI thing? So yeah, we bin these draw commands into screen tiles, right? So the problem is these screen tiles are fixed allocated to like 4K resolution. So what we want to do is do this at we want to allocate these tiles every frame using the temporary resources now. So if I take this, Same with these draw command, these things as well. Tiles cap. So all of these guys can be called init temp. And we'll get rid of all this extra stuff. Just a bunch of buffers. So the size doesn't get placed in here yet. And then when we start actually using the UI shader, we'll say temp buffer alloc and pass in proper sizes of things, which would be nice. So if we take these things with us on a journey, oh, they need another thing. Damn it. Whoopsie. What? Cool. So here we go. Let's move these around. So this is when we initialize the whole. Oh. Yes, this is when we initialize the graphic system. Now when we render a frame, we can go to frame, start, and some of them will go here when we actually do an upload, but other ones will go a bit further on. So I think we'll dump these ones here. So these ones are these three here. These three get uploaded to, there's an array of draw commands, draw words, and clip words. There's clipping too. So these come from right, do a thing to count everything up, allocate everything properly. So, oh, so we no longer have this too many draw commands thing. This is amazing. Unless they're used elsewhere. Right, they're used internally in the right, in the UI system. That's okay, we'll keep that around. I don't mind back keeping these ones, because they're... Yeah, we'll leave these ones here. In the UI system, that's okay. So... now we should be able to use these and only allocate exactly what we need from the temporary heap. This frame. So unfortunately these are gonna... oh wait, have these got to be static? Well, they're uploaded to every frame. No, they can be temp. So they'll be copied to... so we get rid of these, and then yeah, they'll be uploaded to, basically, using the staging buffer. Now we'll take these guys with us. So realistically, we could probably do the upload later on for these. Because the UI is at the end of the frame, so what might be ideal is that actually we stick it here, yeah. Just take it all. Yeah, I don't think this is put into the globals, but if it was put into the globals array, maybe you could already work this stuff earlier anyway if you wanted to. I don't think that's that bad. To do calculate these based on the screen resolution? What have I done? What have I been doing? Oh, right. The size. Right. Yeah, the dimension of a tile of it is square. All right. Right, so we should be able to take all of these then, as I wanted to do, and move it. Move it to when we actually do some UI work, and that means all that sort of geometry rendering can write to many textures, and then later on they'll just, or buffers maybe, and then it could potentially in the future get reused. Yes, the UI rendering will begin here basically. UI from here, and do the upload to the glyph texture. Do the that does the uploading. Allocate the chunk draw commands and the tile draw commands buffer when we do the binning. Perform the binning. Maybe I should rename those back to be in size for now. Damn it. Can't be asked to change it everywhere. Alright. Back to where we were with the UI. Right, so we calculate how many tiles we're going to have in total. So that is the size of the screen at this point. So this would be using the, what are we rendering to? Yeah, why is the BVH ray tracer done so late? Why is it done there? What? Yeah, a lot of this stuff doesn't make any sense. Why are we doing the tile binning so early? We can move it. So we do that here probably. Right. So UI render does some color picker stuff. Right, copy to the... Was there some UI? Good. And it will use the output dims, which is surface dims. Nice. So we take those surface dims. The surface dims X times surface dims Y. Then we do a divide roundup of the minimum tile size. Do we need minimum tile size? You've already got the size of a tile. You don't need these anymore, I don't think. Nope, it's good. It's good to get rid of stuff we don't need. Cool. So this would then be whatever that UI tile size is. Yep. Well, it should. I really want to change that name to dim. It's the size of a tile along a single dimension. Chunk. Cool. So this gets us how many tiles and chunks we have in a single buffer. Maximum number of commands per chunk per tile. Allocate. Yeah, we could probably redo this with the AMD sort stuff, to be honest. We could... Because this draw command's the U32, isn't it? Yeah, we can change it to use the sorting operation, and that might be quicker. Like we're going to do for the ellipsoids when we bin those into tiles. Right, so the chunk binning. Right, I think that's it. Cool, let's see how that goes. Let's give it a run. Yeah, if the stream dies, we'll be right back, but this should be it. Right. Someone didn't undo his dim thing fully. Alright, here we go. Right, so something is not initialized when it's being used. Render frame 749. Excuse me. Yeah, I think we need to make a new compute shader. So in frame initialize, we set up the tiles list we set something to be mean 1. Yeah, the atomic counter. So there's an atomic counter and we atomically add. We atomically increment the counter in the 0 slot and put in tile indices or something like this. So we probably need a frame initialize. Yeah, I wonder what it would take to read it into the keys, into the parallel sort thing, but oh well. All right, let's get rid of that from there. So we'll call it UI setup. I wonder where they are. I can't see them. UI chunk binning, great. So we just send one. I removed the wrong thing. To be honest, the counter could just be moved to the global buffer. Yeah, let's move it there. UI list. So in frame initialize, we'll just do something like this. Essentially that's a 0 every frame. And then this right. Nothing has to get passed into that anymore. Well, I can use that no. That doesn't matter. We'll leave it there. Cool. So the UI setup doesn't have to exist. We don't have to make that shader anymore. So in frame initialize, we don't have to synchronize on this buffer here or pass it in. And what it means we can do is in the shader code, temp buffer alloc, where do we do that +1? Tiles list, where we don't add the 1 anymore because the first index is not going to be an atomic counter. It's in the globals buffer now. It's globally available. So inside the shader code, we'll use this UI list thing. Tiles list. All right. Let's give it a slightly better name. Right, so we're looking for UI tiles list. Huh? Oh, it's just tiles list. Gotcha. Right. So this is when we're doing the binning, which I'm hoping we can get rid of in the future. We don't need it. It's just going over all. It gets the bounding box with the draw command and iterates over all the tiles and bins it in. It's quite a poor algorithm, to be honest, but it works well. It works okay for the UI since it's not that draw command heavy. Atomic add to a global, so graphics global UI tile list next index, so atomically adds and gets back an insert index. Nice. And then that actually does an insert. The insert, yeah, it's good. Then this one reads the counter, so that is just a read operation on the global. So it's in UI render. Got to make sure that we've got the sync code on there. So that doesn't exist anymore. That's good. No start index you have to care about anymore. Great. So we go back to so UI render and the tile binning. We have to be careful to actually yeah, so we're not syncing on globals here. So this one wants to read globals. GPU global. Then the binner, tile binning, read write on the global. Cool, so I did the right sync code. Right, so hopefully things are all good. Let's go. Okay, so that seems like it's running and not crashing. I'm not sure why the debugged visualization of the UI is wrong. Let me turn off those debug visualizations and just see if the UI actually renders fine. And then we can see why it's black in some areas. Right, so the UI looks alright. Oh, we've got a missing tile up here. This is bad. So it seems like they're not flipped right. Okay. So what could we say? Do we just say it's not allocating enough of the tiles? We're doing a roundup. You might have to do these separate. So you might have to do the divided roundup. Yeah, I'm not sure if we might have to change the order a bit, but maybe. Yeah, so I think you have to do some of this. You do divide roundup, multiply it by the divide roundup of this. But I don't know if that's just the same thing. Right, then with the chunks. I don't know if it was just not allocating enough. Let's try that. I should have printed out the number of oh, that seems to have fixed it. So this area's up here is good. Right, so if we go to the debug drawing stuff. Yes, debug draw the tiles and see how it looks. Oh yeah. Yeah, this is cut out here, but the reason is because the top bar is cut out. This is where the tabs are, but it's flipped the wrong way around. So we've got to flip the debug draw if we're going to make it look right. I don't know why the tiles look like that though, but that might be to do with the coloring. Yeah, I think it's to do with the way I decided to do the coloring, to be honest. It's just not perfect. That's cool. So, well, in the UI shader, Yeah, I do flipping of coordinates here, which I don't need to do the flip anymore. Because of the way the new texture storing stuff works. Which is great. It's far better. Right, so they won't be flipped anymore manually. There we go. So these tiles up here don't render anything in the UI system. Compute shaders are only launched to handle the tiles on screen, which actually have stuff on it. So if there's only a bit of UI in the game, it's only going to render those tiles. Cool. Right, so that was a good improvement. You know, it's maybe we want to sort of go and make the UI system use the not do the binning manually and use the sorting method that we're going to be using, but I'm okay with this. Otherwise, I'll just keep changing code for no reason. Oh, no, it's completely expected. It's the performance optimization. So the when it goes and does the binning, it figures out, it's able to know which tiles have got any draw commands, and the ones that do get added to that list. The ones that do get added to that tiles list, and it's just an array of tiles, and then we do a draw in a dispatch indirect, which launches this UI render, and then it's able to use the dispatch group index to figure out which tile it is, and then it indexes into the array, gets the tile, and then it goes. Yeah, so we only launch compute shaders for tiles that need shading, basically. I don't know how much better it is, but yeah. Right, so we're in a good place there. I'm gonna go and get that code up on the GitLab for those who are supporting the channel. Thank you so much, guys, for everyone who's supporting the channel. Appreciate it. Yeah. So next stream, what are we doing next stream? Nothing to do with that. So yeah, you know, you see these sort of tile binning things. Wait, actually, let me just double check that all the UI still works. It's all right. Yep. Right, seems okay. Yeah, I think that's all right. Cool. Yeah, screenshots. Yeah, I got the screenshots working. So we got those working earlier. So now you can take screenshots, and we added a feature where you can so say if I change the screen size, take a screenshot, and change it. Let's make it pink. Screenshot. Wait, I removed the other one. But anyway, yeah. It's able to resize static textures now. So we resize the screenshot texture. Every time we take a screenshot, we resize the screenshot texture so it fits the screen that you've taken it for, and saves it out. And also when you load stuff in, it will resize the screenshot texture as well. So that was a cool feature. Yeah, the color issue too. I got rid of the BGRA conversion, and turns out I needed to keep it in. So these textures are in BGRA format. So when it was being loaded back in, oh no, that was the problem. So the textures needed to be in the same format as the yeah, the textures needed to be in the same format as the surface, so the display, because you're taking a screenshot, right? But we've only got SDR support right now, which is like standard. Instead of HDR, right? I forget the terminology now. I'm so tired. See, the SDR format for displays is BGRA on Windows and Linux. So that it wasn't in the right format there. And then also when I load it up from disk, I need to manually do the BGRA conversion from RGBA. Yeah. So that was the problem there with the color issue. So next stream, buffer size cannot be 0. Oh, the UI, no UI rendering. Right, that's a good find. Cool. Right, maybe we should move the UI rendering out to another thing, but then if that's true... The UI rendering is just going to render on top of the... Great. Yeah. It's just going to render on top of the final... Great. Okay, maybe we can do a thing where... Just put it all in an if statement for now. We can move it to a function some other time. So it just writes out to the final frame texture, so that should be safe. Right, so let's close the editor. Right, I think it tried to double free. That's my suspicion. I think he tries to double free here, so you would just simply, technically you would do something like just null these out. Memblock. But if it's static, no, you don't do this for temp, isn't it? All right. Hey, for me, it's really impressive. This is what you've already done. Thank you so much. Appreciate it, Pinkerton. Thank you, sir. Have you got any personal projects you're working on at the moment? Yes, we closed the editor. Good, that works. It was that. Oh. Right. Cool, so I guess we've got this to a place where I can commit that and it's not buggy. Yeah, so in the next stream, which will be Thursday, about 2.5 hours ago, Thursday, and about 4 hours ago on Sunday. But Thursday, we're going to start on taking a bunch of ellipsoids and bending them into screen tiles and rewriting the renderer, which renders this. This one renders about 8 milliseconds right now. It's horrible. It's got some glitches as well. I can't see those glitches actually. Are those gone now? No, they're still there. Yeah, so we're going to rewrite this ellipsoid renderer. It's going to be using the original tile binned renderer that we did right at the start, but obviously with the improvements that we did later on, and using ellipsoids instead of spheres, and be using PBR and these lovely materials. Yeah, and we'll be going over that whole new renderer. We should be adding AA to it as well at some point, and doing transparent draws in a separate dispatch, I think. But yeah, we'll be going all over that next stream. Cool. But yeah, if you want to come and hang out in the meantime, there's a Discord channel where we talk about stuff off stream at times. And yeah, I'll put the code up on the GitLab for those who have access. I appreciate you guys who support me. Yeah, I'm not sure what that spike is, but I think that is the BVH one. I'm not sure. Maybe it's not. How are you still motivated? Or just willpower? Well, I just really enjoyed doing, like, making stuff. Like that's where the willpower comes from. I just like learning things and doing things. I've been doing it, and I've been doing that for so long. I think I've been programming for probably about 15 years now. That yeah, I've been programming for like 15 years now. That I spent a lot of time just trying to learn a bunch of different things, like about game development, operating systems, and programming systems, programming, that sort of thing. Different programming languages, just really learning a whole raft of things, and also making tons of prototypes of things that I didn't really want to carry forward to the end because I didn't really like the idea. But yeah, now I guess the willpower is still there to learn more things. Now it's lately about graphics, but this project is something I want to actually carry through to the end and build up into being something bigger, hopefully. But we'll see how that goes. But yeah, in the long term, I'm hoping that this project will be something more than just me. That's the aim. Because yeah, I won't be able to finish this by myself. There's too much stuff. I just want to set it up such that it can be planned out and then maybe executed by multiple people, not just me, because I can't do all of the things. No, your English is perfectly fine. I didn't realize you was not English, so that's all right. But yeah, welcome, Pinkerton. Welcome to the channel, sir. See if there's someone on. Right, it's red teacup. Cool, guys. Yeah, have a good Wednesday. Hopefully see you all Thursday. And yeah, if I don't, hopefully have a good weekend and I'll see you all on the Sunday. Right. Have a good one, guys. Catch you later. Bye-bye. Boom.